Have you ever gazed up at the night sky and felt a sense of profound wonder? A feeling of smallness, yet connectedness to the vast, silent tapestry above? For millennia, we believed our solar system, with its familiar worlds, was the blueprint for all others. But the cosmos, in its infinite creativity, has painted a gallery of worlds far stranger, far more extreme than our ancestors could have ever imagined. We stand on the precipice of discovery, peering through the cosmic keyhole, and what we're finding is rewriting the very definition of what a planet can be. These are not just distant points of light. They are places, with weather, with geology, with stories waiting to be told. My name is Albert, and welcome to Unknown Facts. Today we embark on a journey beyond the comfortable confines of our cosmic neighborhood. We will visit worlds where it rains glass sideways, where oceans might be made of diamond, and where ancient planets orbit the remnants of long-dead stars. If you enjoy journeys into the unknown and unraveling the mysteries of the universe, please consider subscribing to the channel and giving this video a like. It helps us continue our voyage into the great cosmic ocean. Our first destination is a world that seems beautiful from a distance, but harbors a terrifying secret. Imagine a planet, a deep, mesmerizing azure blue, reminiscent of our own tranquil Earth as seen from space. This is HD 189733b, located about 63 light-years away. Its captivating color, however, is not from gentle oceans of liquid water. It's the signature of a hellish atmosphere, a sky colored by silicate particles. Think of it as a world shrouded in a haze of microscopic glass dust, scattering blue light in a deceptively familiar way, a cosmic siren luring us closer. The winds here are not gentle breezes. They are ferocious supersonic gales, screaming through the atmosphere at over 5,400 miles per hour. That's more than 7 times the speed of sound. The true horror of HD 189733b is its rain. It doesn't rain water here, it rains glass. These droplets of glass are then whipped sideways by those supersonic winds, creating a perpetual storm of flying molten shards. It's a horizontal blizzard of glass, a nightmare landscape where the very air is filled with deadly projectiles moving faster than a speeding bullet. Next on our tour of cosmic oddities is a planet caught in a slow, inexorable death spiral. Meet WASP-12b, a world that is being actively consumed by its own parent star. Located about 1,400 light-years from Earth, this planet orbits its sun so closely that its year is just a little over one Earth day. The immense gravitational pull from its star is physically distorting it. WASP-12b is being stretched into an egg shape, its atmosphere being stripped away layer by layer. A river of gas is being siphoned off and funneled directly into the star. It's a cosmic feast, and the main course is an entire world. The side facing its star is roasted to temperatures exceeding 4,000 degrees Fahrenheit. It's hot enough to break down hydrogen molecules into atomic hydrogen, but perhaps its most startling feature is its color. WASP-12b is one of the darkest planets ever discovered, absorbing over 94% of the light that falls on it. It's a planet made of asphalt in the sky. Imagine a world where the most prized gem on Earth is as common as rock. Our next stop, 55 Cancri E, has been nicknamed the Diamond Planet, and for good reason. This super-Earth, about twice the size of our own planet and 8 times its mass, orbits a star just 40 light-years away. Initial observations led scientists to a stunning hypothesis, that this world could be composed largely of carbon, and under the immense pressure and heat of its interior, much of that carbon could be compressed into diamond. Think about that for a moment. A planet where mountains might be made of diamond and graphite, where a vast global ocean of molten treasure might lie beneath a crystalline crust. 55 Cancri E orbits its star in a blistering 18 hours, meaning its surface is a searing inferno. The dayside temperature reaches a staggering 4,400 degrees Fahrenheit, hot enough to melt most metals. In our quest for bizarre planets, we now travel not just through space, but deep into cosmic time. We journey to a globular cluster, a dense, ancient city of stars called M4, some 12,700 light-years away. Within this stellar metropolis resides a planet so old it defies belief. Its official designation is PSRB 1600-2026b, but astronomers have given it a more fitting nickname, Methuselah. Methuselah is estimated to be about 12.7 billion years old. To put that in perspective, our own Earth is a youthful 4.5 billion years old. The universe itself is only 13.8 billion years old. This means Methuselah formed less than a billion years after the Big Bang. It is a first-generation planet, born at a time when the universe was fundamentally different. Methuselah doesn't orbit a normal sun-like star. It orbits a binary system of stellar corpses. One is a pulsar, the rapidly spinning remnant of a massive star that went supernova. The other is a white dwarf, the collapsed core of a smaller star like our Sun. This planet has survived the violent deaths of not one but two stars, and now gracefully orbits their remains in a wide, stable orbit. Prepare for a world that gleefully violates our earthly intuition. Our next subject, Gliese 436b, presents us with a paradox so profound it sounds like science fiction. A planet covered in burning ice. Located a mere 33 light-years away, this Neptune-sized planet orbits its red dwarf star at an incredibly close distance, completing a full revolution in just 2.6 Earth days. This proximity roasts the planet to a blistering 800 degrees Fahrenheit. So where does the ice come from? This isn't ice as we know it. We're accustomed to water's phases based on temperature alone, but there's another crucial factor: pressure. On Gliese 436b, the planet's immense gravity compresses the water molecules with incredible force. This colossal pressure crushes the water into a solid state, even at those hellishly hot temperatures. This exotic material is known as ice-10 or other high-pressure ice polymorphs. For generations, a single image from science fiction has captured the imagination of stargazers: a desert planet with a hauntingly beautiful double sunset. For a long time, this was pure fantasy. But the universe has a fondness for bringing our fiction to life. I present to you Kepler-16b, a real-life Tatooine. Discovered by the Kepler Space Telescope, this planet is the first confirmed example of a circumbinary planet, a world that orbits two stars. Imagine standing on the surface of Kepler-16b. As you look up, you wouldn't see one sun, but two. One star is a K-dwarf, smaller and cooler than our Sun, glowing with an orange hue. The other is a red dwarf, smaller and dimmer still. The daily cycle would be complex and beautiful. Sometimes the two suns would rise and set together. At other times, one might be rising while the other is setting. The shadows you cast would be complex, sometimes single, sometimes double, stretching and merging as the two light sources moved across the sky. We've seen a world of glass rain and a planet of burning ice. Now we travel to a place defined by an absence. Our destination is Tres-2b, a world that holds the title of the darkest known exoplanet. It is a world of perpetual, overwhelming darkness, a lump of coal in the cosmos. While most planets reflect a significant amount of light, Tres-2b absorbs almost all of it. Located about 750 light-years away, Tres-2b is a Jupiter-sized gas giant orbiting its star at a very close distance. This proximity heats its atmosphere to over 1,800 degrees Fahrenheit. It reflects less than 1% of the light that strikes it. To put that into context, fresh asphalt reflects about 4% of light. Even the darkest black paint reflects more light than this planet. Tres-2b is, quite literally, darker than coal. Planetary systems, we are taught, are relatively neat and tidy. Planets form in a disk around a star and tend to stay in roughly the same plane. But the universe loves to break its own rules. Our next world, HD 106906b, is a planetary rebel, an outcast that is rewriting the book on how solar systems are put together. This planet is engaged in extreme social distancing from its parent stars. HD 106906b is a behemoth, about 11 times the mass of Jupiter, orbiting at a staggering distance of more than 730 times the Earth-Sun distance. This incredible distance poses a massive problem for our theories of planet formation. Planets are supposed to form from protoplanetary disks, but those disks don't extend out that far. There wouldn't be enough material to form such a massive gas giant. One theory suggests it formed much closer to its stars and was then violently ejected outwards through gravitational interaction. It would be a planetary exile, kicked out of its home and sent screaming into the outer darkness. but somehow manage to cling to a stable, distant orbit. For our final destination, we visit a world that could be a glimpse into a completely new class of planet, one dominated by the most essential ingredient for life as we know it, water. Let's travel to GJ 1214b, a super-Earth that has been nicknamed a water world. This isn't a planet with oceans like Earth's. Scientists believe this is a world that could be composed almost entirely of water, from its core to its atmosphere. GJ 1214b is larger and more massive than Earth, but significantly less dense. This low density strongly suggests the planet is made of something lighter, water. Imagine a world with no continents, no land masses, just a single global ocean thousands of miles deep. Beneath the surface, the pressure would compress water into exotic forms of high-pressure ice, creating a world with a liquid ocean resting on a mantle of solid, hot ice. The atmosphere of GJ 1214b adds another layer of mystery. Observations show the planet is shrouded in a thick blanket of clouds or haze. It's a world perpetually encased in thick, hot fog, creating a planetary-scale sauna. While it's too hot for life as we know it, its existence suggests that water worlds could be common throughout the galaxy. Our journey is over, but the story of these worlds is just beginning. From the sideways glass storms of HD 189733b to the ancient loneliness of Methuselah, each planet we've visited is a chapter in the grand cosmic story. They are more than just bizarre novelties, they are crucial data points that expand the boundaries of our knowledge. These discoveries are a profound testament to the power of human curiosity and the relentless spirit of scientific inquiry. We are a species that looks up at the lights in the sky and doesn't just see twinkling dots, we see destinations. We build instruments of incredible precision to decode the light from these distant worlds, to learn their temperature, their weather, their age, and their composition. What other wonders are out there waiting to be found? Planets made of stranger stuff still? Worlds with even more impossible weather? If you found yourself captivated by these cosmic wonders and want to continue exploring the unknown with us, please show your support by subscribing to the channel and liking this video. Thank you for joining us on this cosmic journey.